Hey guys, all right, today we are covering 510 proportional relationships, which is just the more mathematical name is it's called direct variation, okay, which we'll get into more in algebra next year, but that is what it's called as well. Okay, so for things to be proportional, where's my highlighter? For when quantities are proportional, they have a constant rate or ratio, which means when it says constant, that means they have the same rate or ratio. When they are non-proportional, they do not have a constant rate or ratio. Okay, so the minute that they're not the same, you don't have to go any further, it's not proportional. All right, so let's look at this. For number one, in order to figure this out, okay, you're going to set this up. You want to set the ratio up. So we're going to do, this is the right, I'm sorry, the left, this is X, this is Y. We're going to do the money over pounds. So I've got to see, is the ratio all the same? Okay. So we set this up as 6 over 1, which is 6. Okay. Then it's going to be 12 over 2. Oh, that simplifies to 6. 18 over 3. That simplifies to 6. 24 over 4. That simplifies to 6. And we notice that they are all the same. Since they are all the same, this is yes, it is proportional because you want to determine if the data represents a proportional relationship. So we have a yes-no scenario. If yes, we have to say what the constant rate is. So for us, the constant rate for this is $6 per pound. This is my final answer. If you need to re-listen or have you any questions, just come up and ask. Remember that you can pause it and re-listen to it if you need to. Okay, number 2. So we have 595. Oh, this is X, this is Y. We're going to do the money over miles here. Is my ratio. 595 over 4. And I'm going to do that. We're going to get you a calculator and we're going to see what that equals. 5.95 divided by 4. And that is, we're dealing with money here. So this is going to be 1.49. Next we have 9.15, $9.15 over 8. Well, one thing I could notice is I'm doing times 2 here to get to this. If I do times 2, that's not going to be the same. So that's one way to quick know that, but we've got to prove it. We have to mathematically prove it and show this, what this equals. 9.15 divided by 8, and that gives me 1.14. These are not the same. Not same. So therefore the answer is no. Again, if you have any questions, please make sure that you come and ask or you re-listen. All right, moving right along. Okay, we talked about how direct variation is another name for a proportional relationship. Okay, so proportional relationship is the same thing as direct variation. Direct variation has a specific equation or formula. Okay, it says when direct variation is when two variables vary directly. Very directly, those words tell me that this is proportional. Direct variation, those are my clues that this is the type of situation that's happening. Their relationship can be expressed through the following equation. Y equals KX. One thing you may notice is this equation looks similar to the slope-intercept form. So a little note we're going to add here is K is in same spot as M, so it is slope of a direct variation, dv. You'll see me write that. dv is direct variation graph or problem. All right, so here we go. Let's finish this out. Okay, so the equation is actually read this way. It is read as y varies directly as x. That's what that means when it's saying that, okay? The k is the ratio of y to x, which is what we've been finding up here. So we have that k is found y over x. And it is referred to, the mathematical name for it, excuse me, is constant of variation. I don't know why it's not a C, but it's a K. K, constant, K, k, k. One way you can think about it there. All right, so here we go. Let's get some answers going here and see how this was going to work out. Okay, number 4. It says, determine whether the values in the table represent a direct variation. So we're going to have a yes-no situation. If yes, give the constant and write the equation, okay? The thing to remember, when you write that equation, okay, it must be y equals kx form. The only thing that you're changing is the k. You're still going to have the y and the x written, okay? Only change k. Okay. All right, here we go. Let's work on this. So to look at this, well, let's see. The number of tires depends on what type of bike you have. So this is X, this is Y. So we're going to have 2 over 1, which is 2, 4 over 2, which is 2, 6 over 3, which is 2, 8 over 4, which is 2. Well, since all of these are the same, it is yes. And the constant is 2. Oh, this is number of bikes. 2 tires per bike. But that's not my equation. This is the yes-no answer. Part A is the constant. Now we have part B, which is the equation, which means this is telling me that k equals 2. So my equation is going to be y equals 2x. This is the equation, not with any of these numbers plugged in. Just y equals 2x is my equation. Okay, next example. We're going to jump to number 6. Okay, notice you have 0, 0 here. Just kind of ignore that because that's a special type of scenario. We're not going to look at that, so ignore. Okay, because we have to have some numbers to deal with to be able to figure out. So we're doing trying to figure out what the ratio would be. So I'm going to do 110 over 2. That's going to equal 55. Then I'm going to do 214 over 4. I don't know what that division is, so handy dandy calculator. 214 divided by 4. Enter. That is 50. Hold up. Eraser's not very good. That is 53.5. These are not the same. Not same. So therefore, this is not the same ratio. So therefore, the answer here is a no, and I don't have to go any further. Again, if you've got a question, rewind or come ask me. Next part, we're going to look at some word problems dealing with this. Okay, looking at number 7. Excuse me. Make sure we can see this well. Okay. The total cost for tickets to the dance varies directly. Remember, it's Y varies directly with X. So whatever's in front is the Y, whatever's behind it is the X. So therefore, the total cost is my Y. Tickets to the dance varies directly to the number of tickets, which is my X. This helps me tremendously when I'm having to find out what is my ratio. So we have to label the variable. So we're going to let X represent, we have to write this up. So X equals the number of tickets. Y is the total cost. All right. So now remember, we're wanting to write, okay, if 5 tickets cost $15, identify the constant of variation. So that means I'm trying to find out what K equals. And I need to write the equation, which means that equation is going to be in the form of Y equals KX. And I just plug in the K. So to find the K, remember, I've got to figure out, okay, where is it talking about? So I've got 5 tickets, cost $15. So I'm going to have, to find the K, I'm going to have the $15 over the 5 tickets, which is going to give me $3 per ticket. So I have that K equals 3. So now I'll plug in and I'm going to get my equation of Y equals 3X. So this is everything that's expected for the problem. You label your variables, show your work for finding K, and then the only thing you plug in is the K, not the 15 and the 5 in here. It's the, excuse me, the K of 3. All right, here we go. Because remember that K is found by doing Y over X. I didn't write that down. I should have. Okay. Moving on, we're going to jump down to number 9, where we're going to do the same thing we've just done here, but we're going to add a step where we're going to now find an answer using this equation. Okay. In a car wash fundraiser, the money earned, so the money varies directly with the number of cars washed. So I'm going to let X represent, because and remember, it goes Y varies directly with X. So this is Y and this is X. So it's number of cars. Y is the money. Remember to find K because it wants us to determine how much money is made when 15 cars are washed. So we want to find the money when 15 cars are washed. Well, in order to do this, we have to first, and information. 4 cars are washed, $14 is made. So what we've got to do is first find K. Second, write equation. Third, solve. That's our steps. K, remember, is found Y over X. Well, we just said that the Y is the money, and we know that $14 is for 4 cars. Well, I want to simplify that, so I'm going to do the division. How much is it for 1 car? 14 divided by 4. So that's $3.50 per car. Now, to write my equation, I'm going to take this and plug it in to the formula of Y equals KX. So I'm going to have Y equals 3.5x. This is the equation, okay? Remember, this is the equation. People get very confused on writing the equation, so I'm trying to make sure you understand that. Now we're going to solve, okay? So this was step 1. This was step 2. Now step 3, where we're going to plug in the 15 cars. Okay, so we're going to have y equals, because remember x represents the number of cars, so I'm going to have y equals 3.5 times 15, which gives me the y value of that cost is going to be $52.50. There's my final answer, but you have to have all of these steps in there for working that problem. Okay, that took care of word problems. Now we're going to talk about graphing direct variation equations. Okay, and then we're done. All right, so it is important to understand that a direct variation equation, which is in that form of y equals kx, is it's just a special type of a linear equation, which is in the form of y equals mx plus b. They all represent a line. So your graph is supposed to be a straight line. When I'm looking at this, the y-intercept is always 0, okay? So when I've got an equation, it's understood to be plus 0, we just don't write it. The slope is k, so that's the same thing. So when I'm looking at number 11, it's understood to say y equals 4x plus 0. So when I'm wanting to graph this, I can now pull out and say, okay, my beginning point that I start with is 0. My slope is 4. Remember, slope is rise over run. So I have to make a fraction. So this is going to be 4 over 1. So this is where I'm going to tell myself the positive. So this is going to be up 4. Oh, shit. Give me just a second. I'm going to erase that and make more room. So it's not so jumbled. Having to get back in the groove, guys. I apologize. 4 over 1. So we have up 4 to the right 1. So, and always start from the beginning point. It's not, okay. So we have 0. It's my first point. All I have to have is 2 points to graph a line. So I'm going to go up 4, 1, 2, 3, 4. And you can always show your little loops if you need to make sure that you're accurate. To the right 1, there's my next point. It can always go in the opposite direction as well, because you want to be as accurate as possible. And your graph is to go through the entire line graph. Excuse me, this is my straight edge right here because I don't have a ruler and I want to be as accurate as possible. And there's my graph. Okay, here we go. One last problem, guys. 13. The reason I picked 13 for y'all to look at is because there's no number written there in front of the x. This can be rewritten as y equals negative 1x plus 0. So you know what you're pulling out of it. The b is 0. A direct variation always goes through the origin. Okay. dv always goes through origin. If it's a direct variation equation, you know it's going to always go through the origin. So we know that the b is 0. Now my slope is negative 1 over 1. So that means I'm going to go down 1 to the right 1. Down 1 to the right 1. Now, if you're not sure, you know that your graph better look like this. It better go downhill. If you end up with a graph that looks like this, but I have a negative slope, it should be, I made a mistake. All right, oops. And you just continue that pattern. Since it's so easy at this point, this slope is, so that your graph is as accurate as possible. And then we play connect the dots, is what I like to call it, because your graph has to go all the way through the coordinate plane. Okay, your assignment is to finish the classwork, finish the notes and the classwork homework. Y'all have a great day.